This video is broken into two parts. Part 1, we will explain the concepts. VPC, route table, security group, NACL, NAT gateway, their differences, examples, etc. Part 2, things gets interesting, where I will ask you how the traffic will flow given the scenario, and explain different real-world VPC traffic flow patterns. If you already know about VPC components, go to the Part 2 timestamp. But if you cannot answer the traffic flow quizzes, then please watch from the beginning, because these are fundamental AWS networking concepts which you will be asked in your AWS assessment test and interviews. With that being said, let's get started. Welcome guys and girls to one of the most important concepts of AWS Cloud, VPC or Virtual Private Cloud. AWS has multiple regions spread throughout the world, and a region refers to a geographic area in a country. And let's take a region, and we also know that inside a region is one or many availability zones, and each availability zone is comprised of one or many data centers. Now, let's say you want to deploy your application in one of these regions. How will you deploy it? If you have to mention that, hey, I want to deploy this application in this data center of this availability zone or that availability zones, it will be very tedious. You have to have some way of logically defining a boundary inside this region where you can deploy your applications. And that's what VPC is. VPC stands for Virtual Private Cloud, and that gives you a logical boundary inside this region where you can deploy your application. Now in this diagram, I'm showing this VPC is encompassing both the availability zones, but in reality, each availability zone is huge and meant to be shared across many customers. So this is actually how the settings look like. One availability zone could be spread across multiple VPCs, shared by one account or multiple customer accounts. But for simplicity, let's go back to this diagram. And when you create a VPC, you need to say, hey, this VPC will be using part of this availability zone 1, availability zone 2, etc. And you need to have a chunk of IP addresses. That's how AWS knows that this is your logical boundary. So you have to say this VPC is using IP address range of 172.31.0.0/16. So this will give you a certain number of IP address to this VPC, and that's yours. Other customers cannot use IP address range from this VPC IP address range. Even part of availability zone is huge. You need to define sub-ranges inside the availability zone. You have an option here. You can create one subnet assigning an IP address range from that main range inside this availability zone, or you could create multiple subnet inside one availability zone. If you are curious how many IP addresses are there inside this entire VPC CIDR range or within these specific subnets, you can go to this website ipaddressguide.com/CIDR, and in the CIDR field, you can give the VPC CIDR. For our case, the VPC CIDR is 172.31.0.0/16. If you click calculate, so there are 65,536 IP addresses. This is the first IP address in this range, and this is the last IP address. All right, going back to the slides, two things to keep in mind. First, one subnet can only belong to one availability zone, because you understand that each availability zone is a set of separate data centers, so they cannot really overlap with each other. So subnet 1 belongs to availability zone 1, subnet 2 and 3 belongs to availability zone 2, so they cannot belong to both availability zone 2 and availability zone 1. Second, there could be no overlapping IP address between these subnets, because when you provision a resource such as Amazon EC2 or AWS Lambda inside this subnet, they consume IP address from the IP address range from this subnet. As we learned by now, IP address should be uniquely identifiable for each computer or a resource, so you cannot have two same IP address from different subnets. Else, if someone is trying to access EC2 and the same IP address is attached to two EC2s, you cannot reach it. So that's why all the subnet IP address ranges must be non-overlapping. All right, let's remove the IP address ranges for the explanation. Remember, the whole purpose of VPC is to carve out an area for your application, and it also implies security. So when you create this subnet, you have to have a couple things attached to it. The first is a route table which defines where should the traffic go, and the second thing is NACL or network access control list, and then inside the subnet and attached to each of these resources such as EC2 and Lambda, you'll have security group. So even for subnet 2 and 3, you will have route table NACL and a security group attached to other resources inside other subnets such as subnet 3. And it also shows that you can have an empty subnet. You can define a subnet and keep it empty, but remember, you are just wasting away IP address then if you don't use those subnets. If you notice carefully, you will see that the color of route table and NACL for subnet 1 and subnet 2 are same. What that means is the same routing rules and same NACL could be attached to multiple subnet, whereas subnet 3 has a separate route table and separate NACL. Similarly, for the security group inside subnet 1, both the EC2 and Lambda have the same security group, whereas the security group of the EC2 inside subnet 3 is different. So now let's take a look at how the traffic flows. Remember, each machine has a separate IP address. So let's say you, as a customer of the application that's running inside this EC2 in subnet 1, is trying to reach this EC2. As a customer, you will also have an IP address, which is for your laptop or desktop. For your subnets to be accessible from internet, you need to have an internet gateway. So internet gateway will be at the VPC level, and each internet gateway, and you only need one internet gateway, and this internet gateway will have an ID. In this case, this is IGW1. If your subnet needs to be accessible from internet, it needs to be attached to this internet gateway via route table. So you do not go and attach this internet gateway to these individual subnets. You define it inside this route table. So let's take a look inside this route table. So this route table has two rows. The first row, the destination is 0.0.0.0/0, which means internet. And the target is IGW1. That means destination is internet. So any traffic originating from the subnet, which is going to the internet, will be routed to IGW1 or internet gateway. And from internet gateway, it can go outside of VPC to the internet. Even though this is for outbound, if your route table has this row, that means traffic can reach from internet to the subnet as well. The second row has the IP address range of the entire VPC, and the target is local. That means if the traffic originates from inside this subnet or other subnets from this VPC, they will be allowed to enter to the subnet where this route table is attached to. All right, so at this point, internet traffic is allowed. The traffic goes to the route table, and then it hits the NACL or network access control list. So this is the second layer of defense. Now let's take a look at this NACL. So the NACL, which is attached to subnet 1 or any NACL in that sense, will have inbound rules and outbound rules. You will define what traffic is allowed to enter the subnet and what traffic are allowed to exit the subnet. NACLs are stateless. That means if a traffic goes in the subnet, you would think that same traffic connection should be allowed to exit the subnet, but NACL does not remember which traffic entered and which traffic is leaving. So inbound and outbound traffic will be evaluated separately. And each rule in the inbound and outbound rule tables will have a numeric rule number, and they will be evaluated incrementally. So let's say for the inbound, rule number 110, HTTPS traffic for the port range 100 to 300 from the source IP address range of 10.10.0.0/16 is allowed. Even though the second row says all traffic is denied, it doesn't matter. As soon as a rule with a lower numeric number says allowed, that will be allowed. So in this case, the traffic is coming from 10.10.20.30 is HTTPS traffic going for port 150 in the application. That means this traffic will be allowed in the inbound. And for the outbound, we have a rule which is allowing all traffic to exit the subnet. If the inbound table looked like this, let's say the rule number 100 is allowing all traffic, but rule number 110 is denying this particular traffic. Can you tell whether the traffic will be allowed or not? Yes, it will be allowed because they are evaluated incrementally, and as soon as the lower numeric number says something is allowed, it cannot be superseded by a higher rule number. And the last row asterisk is just catch-all rule. If something is not defined by the rule number, that asterisk row will be evaluated last, and all the traffic that is not allowed will be denied. All right, so going back to the traffic flow, now the traffic connection goes to the route table NACL, and then it hits the last security layer, which is the security group. You can think that as a firewall. So how does the security group look like? Similar to NACL, it will have inbound rules and outbound rules, but here all the rules will be evaluated, not the lower priority rules first, and if it is allowed, it's allowed. For the inbound rules, there are two rules, ID1, ID2. Remember, they are not numeric because everything needs to be satisfied. And for ID1, HTTPS protocol is allowed. ID2, all traffic is allowed. There is no deny rule in security group. Whatever you allow will be allowed. So don't put something that you don't want to allow and it will be denied by default. And outbound rules, everything is being allowed to exit. Now security groups are stateful. Irrespective of whatever rule you define, if a traffic is allowed inside, the same traffic will be allowed to exit the resource. Let's say, for example, this particular traffic is allowed because of the inbound rule, but you somehow denied everything in outbound rule. It doesn't matter. That same traffic connection will be allowed to exit because security groups are stateful. It remembers that, hey, I let someone enter, so I have to let the same person exit out. Similarly, if you allow everything in the outbound rule and deny everything in the inbound rule, as in don't define anything in the inbound rule, and if your application running in the EC2 goes from EC2 to the internet to grab a package that you need to update, it will be exited even if you don't explicitly allow that in the inbound rule. Because it is stateful, it will allow the same traffic connection to enter back the EC2. All right, so going back, so now the traffic reaches the EC2, and now our user is expecting a response back. So at this point, we know that security group is stateful. So it is not going to evaluate against those rules. The traffic was allowed to entry, so it will be allowed to exit out irrespective of the outbound rules. But NACL is stateless. So then it will be evaluated if this traffic is allowed to exit out. So it comes to the NACL, it sees the rule number, all traffics are allowed out, and then it goes to the route table, and the route table says anything that's going to internet goes to IGW1 or Internet Gateway 1. So then the traffic goes to Internet Gateway 1, and through that it goes back to the user in the internet. Now remember, subnet 1 and subnet 2 has the same route table. That means both these subnets have a way to access the internet traffic. That's what makes them a public subnet, that is publicly accessible. That's it. It doesn't mean anything else. There is nothing separate in the subnets. So any subnet where the route table that's attached to that subnet is allowing traffic from and to internet is a public subnet. Now let's say for subnet 3, we have a separate route table. And let's say the route table looks like this. Only row it is there is the local VPC traffic. So it's allowing any traffic from within this VPC to enter into subnet 3, but it is not allowing any traffic from internet. So it doesn't have the row that's allowing through IGW1. That means this subnet is a private subnet. It does not have any access from internet. The resources within this subnet, such as this Amazon EC2, can only be accessed either from inside this subnet or other subnets inside the VPC. So this creates an additional security layer. You will run your sensitive business logic or your databases inside private subnet. And your front end could be running in public subnet. So all the traffic comes to the public subnet, goes through authentication, authorization. Only the application running on the public subnet can access your business logic or the database. Let's take a look at that traffic flow in the next video. In the last lecture, we learned about what is VPC, how the subnets and availability zones are related to VPC, as well as NACL, route table, security group, public subnet, private subnet. Now let's learn how does traffic flow look like when something is being accessed to and from resources in private subnet. Let's say your application running inside this AWS Lambda wants to access some sensitive business logic running inside this subnet 3 EC2. How would the flow look like? First, the traffic flow will be evaluated at the security group of the Lambda. If the traffic is allowed out, then it will go to the NACL of subnet 1. All right, it's allowed outside. Then it goes to the route table. Route table allows any local traffic within the VPC. Then can you think what will happen next? Where will the flow go? Then it will be evaluated at the route table of subnet 3, and subnet 3 route table allows local traffic. And assuming the NACL also allows the local traffic, it will go to the security group of the Amazon EC2 and the traffic will enter Amazon EC2. And how would the response look like? Let's pan that out as well, but see if you can think through it. So the exit traffic from the EC2 will not go through the security group of the EC2 because security group is stateful, right? It has to allow the traffic to exit irrespective of what's defined in the outbound. It will go through the subnet 3 NACL route table. Then what will happen? Can you think? Yep, you got it right. It will go through subnet 1 route table, subnet 1 NACL, and then enter the AWS Lambda irrespective of the security group of Lambda. Because that traffic was allowed to exit the Lambda, that traffic needs to be allowed to enter in irrespective of the inbound rules in security group. So now the question is, what if the EC2s running in the private subnet, subnet 3, needs to access internet? So you will be running some packages as part of your operating system or your application. What if you need to go and grab an updated version of the package, or you need to go update your operating system from the internet? Because this private subnet cannot access the internet directly, you need to go through public subnet. And you do that using a service called NAT gateway. Let's take a closer look at this NAT gateway. The word NAT stands for Network Address Translation. It is named this way because NAT gateway replaces the source IP addresses of the origin to its own. So let's say any resource such as a EC2 from private subnet goes to this NAT gateway. Now the IP address of the EC2 running on the private subnet will be replaced by the IP address of this NAT gateway when that traffic connection leaves NAT gateway. So why do you use NAT gateway? You use NAT gateway for the resources running in private subnet to reach outside the subnet, even internet. So the traffic from private subnet to NAT gateway is allowed, but external resources such as some process running in internet, they cannot reach the resources running in private subnet using the same NAT gateway, because the external resources do not know the IP address of the resources running in private subnet. By default, NAT gateway is created in public subnet, but you can also create private NAT gateway for VPC to VPC connections. NAT gateway is AWS managed and scales automatically. So for those of you who knows AWS from little while back, if you remember, customers or users needed to create this NAT gateway EC2, and if the traffic increases, you need to go create a bigger EC2, all that stuff. But that has changed now. Now NAT gateway is managed by AWS, so you don't need to worry about scaling up or scaling down. NAT gateway is priced on each hour it is available, even though it is not being used. If you just provision one, you will incur charges and the amount of data passed through it. NAT Gateway currently is not under free tier. So if you try to do a demo on NAT Gateway, make sure after the demo you delete NAT Gateway. All right, let's go back into the traffic flow. NAT Gateway will have an ID as well. Let's say NAT1. And in the route table of subnet 3, you will say any traffic that is going to internet designated by 0.0.0.0/0 will be directed to the NAT Gateway, NAT1. So how does the traffic flow look like? Amazon EC2 goes through security group, NACL, route table to NAT Gateway. Now we have to have a path defined in the route table of subnet 1, which will allow the traffic from NAT Gateway to Internet Gateway. And now from this NAT Gateway, which is running in the public subnet, we already have the route table. Anything that is trying to reach the internet will go to IGW1. So the traffic will go from NAT Gateway to Internet Gateway and then to the internet. And then by this time, you folks understand that how the traffic will enter back onto the EC2. So don't get confused by the previous slide when I said that external internet resources cannot reach private subnet through NAT Gateway. This is different because in this case, the traffic connection is initiated by the NAT Gateway to internet. So as a response, it will be allowed to come back to NAT Gateway, and the NAT Gateway will send the traffic to the private subnet. What I meant in the previous slide is resources in the internet cannot initiate a connection to the resources in private subnet through NAT Gateway. All right, I'm curious now. Were you able to answer the quizzes and able to detect the traffic patterns before I showed you the answer? Or did you face some challenges? Are there any other VPC concepts that you have questions about? Let me know in the comments. That's it for this one. I'll see you guys and girls in the next one. Bye.